Motor introduction. Guiding principle. As one of the most important driving forces in our lives and production, motors function to transfer electric energy into mechanical energy, making our lives much easier. A motor is comprised of a magnetic winding, which creates a magnetic field and rotational rotor. Affected by the magnetic field, the current in the rotor rotates and transforms electric energy into mechanical energy. Motors with an output power ranging from milliwatts to kilowatts can be widely applied in agricultural and industrial production, transportation, national defense, business, home appliances, and medical facilities. Motor structure. Among the different types of motors, cage-type three-phase asynchronous induction motors are the most widely used, accounting for 70% of the total. Motors are comprised of a stator, rotor, casing, and fan, of which stators and rotors are the most important components. A stator produces an alternating magnetic field. Relative movement between the rotor and magnet field produces electromotive force and current, and a rotor's interaction with the magnetic field produces torque, transforming electric energy to mechanical energy. Losses. Motor efficiency equals output power divided by input power. The difference between output and input power is loss. Motor losses include stator copper loss, iron loss, stray load loss, rotor copper loss, and mechanical loss. The loss proportions are 15 to 20% for iron loss, 5 to 15% for mechanical loss, 30 to 45% for stator copper loss, 20 to 25% for rotor copper loss, and 10 to 15% for stray load losses. Reducing these losses can effectively improve motor efficiency. Copper rotor motors. Principle. Copper has very good conductivity. The conductivity of annealed pure copper is set to be 100% in engineering, and this conductivity, compared to other materials, is the IACS value. IACS values for pure copper, pure aluminum, and pure commercial aluminum can reach up to 101.5%, 64.94%, and 59% respectively. This means that copper's conductivity is 35% higher than that of aluminum. Currently, aluminum rotors are widely used in three-phase squirrel cage asynchronous motors. The typical manufacturing process to form them is to press liquid aluminum into a die by a casting machine. Since copper has a better conductivity than aluminum, therefore cast copper rotor motors can greatly reduce rotor losses and hence the total motor losses. The use of cast copper rotors can produce higher efficiency, and even premium efficiency motors by using copper rotors can achieve higher energy efficiency for the same motor dimension. Performance improvement. With lowered motor losses, the transfer of thermal energy will be reduced, resulting in lower temperature of the rotor and stator coil. Lower temperature means smaller fans or even no fans need be used at all. In this way, the attrition losses of additional components and air resistance will be reduced to improve motor efficiency. At the same time, a lower operating temperature of the motor will greatly extend its life expectancy and reduce maintenance costs. According to a generally accepted principle, every 10 degrees Celsius reduction in the operating temperature of the motor will double the life of insulated materials. Under normal maintenance conditions, cast copper rotor motors enjoy a longer life and higher reliability. Since copper has a lower resistivity, under the same induction voltage, current in copper rotors is greater than that in rotors made of aluminum. Therefore, fewer materials can be used to produce a motor with the same power and efficiency. The reduction of materials means copper rotor motors have a lower material cost, lighter weight, and smaller volume while providing the same power and efficiency. These advantages of cast copper rotor motors provide more leeway for producers to pursue high efficiency, low cost, and light weight, or strike a balance among the three. Usage. These advantages make cast copper rotor motors suitable for small squirrel cage induction motors to replace the existing aluminum rotors so as to improve energy efficiency. Within the range of power, the use of cast copper rotors is the simplest and most effective and economically feasible manner to produce high efficiency and premium efficiency motors. At the same time, smaller volume, lighter weight, and higher reliability make copper rotor motors applicable in some special areas such as hybrid power vehicles, electric vehicles, nuclear power plants, air conditioning compressors, driving motors, speed change driving motors, and submersible pump motors. Production process. Despite its many advantages, the difficulty of producing cast copper rotors has historically impeded its widespread use, which is why aluminum rotors are so prevalent today. The difficulty in producing cast copper rotors lies in copper purity and a high casting temperature of over 1,100 degrees Celsius, which has been problematic for die in the pressure chamber of casting machines. Aluminum, however, requires only 700 degrees Celsius for casting. The use of aluminum casting material and processes to produce a copper rotor would fracture the die surface in a short period of time. Apart from that, the oxidization of pure copper liquids needs to be prevented, as the cuprous oxide particulates formed in the process of oxidization would exert a dramatic negative influence on copper conductivity. Recently, International Copper Association with Yunnan Copper Die Casting Technology Company and the Nanyang Explosion Protection Group Company worked together to research a copper casting process and address the problems related to high temperature die and casting. The result is a new process that permits the economical, large-scale manufacturing of cast copper rotors. Cast copper rotors can be produced by both vertical and horizontal die casting machines. At present, the improved production process is based on a horizontal die casting machine co-developed by International Copper Association, Yunnan Copper Die Casting Technology Company, and Nanyang Explosion Protection Group Company, and has proven itself to be very successful. Let us explore the production process by using a horizontal die casting machine as an example. First of all, the rotor lamination needs to be assembled to the rotor iron core according to the technical requirements. After applying a die release agent, the rotor core is inserted into the die to prepare for production. Copper is then melted in an induction furnace, and the liquid is poured into the pressure chamber of the casting machine. Driven by the casting machine, the melted copper liquid flows into the die with a set pressure and speed and passes through rotor laminations to form the rotor bar and front and end rings. After casting, the die is opened and the rotor removed, after which the runner and biscuit are also removed, which completes the casting and production process. International Copper Association is devoted to adopting low-carbon energy conservation solutions to promote sustainable development by formulating and implementing relevant standards so as to facilitate the application of latest energy-saving technologies and help consumers select low-carbon products and services. For more information, please log on to our website at www.copperinfo.com.